Today we will be solving absolute value equations. So let's take a look at our first problem here. We have the absolute value of x minus 3 equals 4. Well, we solve these pretty much the same way we would any equation. We isolate the variable. And so in this case, we're going to isolate this entire absolute value. So here I'm going to add 3 to all sides. And so when I do that, I'm left with the absolute value of x equals 7. So now there's two numbers that can go in for x to equal 7. You see, if I took the absolute value of 7, that would equal 7. And I can also take the absolute value of negative 7 to equal positive 7. So that means we have two answers. We say the answer is negative 7 and positive 7. Or, in this case, since they're the same value, just one's negative and one's positive, you could write the answer as plus or minus 7. Take a look at the next one. It's a little bit different. And the reason it's different is because we have more inside the absolute value bars. So as I said before, we always want to isolate the absolute value. Well, it's already isolated here. So what we're going to do is we're going to set up two equations. You see, x minus 2 and 5/10 can equal either 8, like in this case here, the absolute value of 7 equals 7, or it could equal negative 8, because the absolute value of negative 8 also equals 8. So let me show you that again. Absolute value of 8 equals 8, and the absolute value of negative 8 equals 8. So there's two values x could end up being. So just as there are two values over here. So what we're going to do is we're going to do x minus 2 and 5/10. We're going to set that equal to 8, but I'm also going to set it equal to negative 8. And I'm going to solve two equations at the same time. That's why I put the equal sign on both sides. So I'm going to go ahead and add this 2 and 5/10 to this side, and then I'm also going to add it to this side over here. Now you got to be careful with this one, because when they're the same sign, again, we just add, so it's 10 and 5/10. But on this other side, we're going to end up having to subtract. So you got to borrow, and that's where you have to be careful. So this is going to be a 7, and so we end up with x equals 5, negative 5 and 5/10. But it also equals 10 and 5/10. So negative 5/10, negative 5 and 5/10, and 10 and 5/10. Those are the two solutions. So sometimes we write solutions as a solution set, and so I'll get in the habit of doing that for right now. And so those are our two answers. Over here again, we're going to isolate the absolute value. So I'm going to subtract 2 from all sides. And I bring down that minus sign, the absolute value bar, the 2x minus 5, and this all equals negative 6. So I still need to isolate that absolute value. So you could distribute the negative sign inside, but what I'd rather do is just divide by negative 1, and that will cancel out these negative signs, leaving me just with that 2x minus 6, or minus the 5. It just makes it easier for me because I have less negatives to deal with, and the variable is positive in this case. So this was a good thing because the negative signs cancel out to make a positive 6. So now I'm ready to solve. Remember, just like the last one, there's two values we could put in place of that 2x minus 5 to equal 6. See, it could either equal 6 or negative 6 inside the absolute value bars. So that's why I'm going to set that 2x minus 5 equal to both of those values. So when I go ahead and solve this, I'm going to do those two steps here. I'm going to add 5 to all sides. And so when I do it to this side, I end up with that negative 1 equals 2x, which also equals 11. And so from that point, I'm going to just divide by the 2, and I've got my two answers there. So you can see that one's a fraction, negative 1/2, and the other one is an improper fraction, 11/2. And so those are my two solutions that I can put in place of x to get, and then do the work inside the absolute values, then take that away from 2 to get negative 4. Well, looking at this next one, again, the first step is always to move that 3 over, in this case, to isolate the absolute value. So now we've got the absolute value isolated. See how x plus 1, the absolute value of it, equals now negative 1. But we have a problem here. Does anyone see that problem? Well, the problem is right here. See this negative sign? You can't have an absolute value equaling a negative. And since it just has that, we don't have anything else attached to the absolute value to change that sign, we cannot solve this. And so what we'll say is that there's no solution. No solution, no value of x that we could put in for this x here, add 1, take its absolute value, add 3 to get positive 2. So no solution. That is our answer. Or we could say the empty set, showing that there's no value inside those braces. Let's take a look at our next one here. Here we're going to add 6 to all sides. So if I add 6 to that negative 6, I get 0. Sometimes people think this is a no solution as well, but it's not. So you could get an absolute value equaling 0, and here's what we're going to do. Now, there's only going to be one answer here, one value to make 0, and the reason is that there's only one 0. There's no positive 0, there's no negative 0, it's just 0. So let's go ahead and figure out the value of x. We just set that x plus 4 equal to that 0, and subtract that 4, and there's only one number. So you can only put negative 4 in place of x to make 0. So that is our only solution here. Next one here, we're going to end up subtracting the 9 from all sides, and we get that same situation here where we have 4x, the absolute value of it, equaling 0. Difference here, the reason I picked this one, is that we actually do get a value, an answer of 0. You see, when I go ahead and solve, 4x equals 0. When I divide by 4, notice that I'm dividing by 4, not 0. So 4 does go into 0. It goes in there 0 times. So that is our solution. So oftentimes people think this is a no solution also, but it's not. No solution is only when the absolute value is going to equal a negative, like it did on this problem over here. Well, here's a typical type of absolute value equation problem I would see. And so here we already have the absolute value isolated. So we're going to take that 3x plus 1, set it equal to 13, but also set it equal to negative 13. So when we go ahead and solve this, we're going to subtract the 1 from all sides. And so notice that when I have the two negatives, I end up adding those two numbers to get negative 14 equals the 3x, which also equals 12. So I've got just one step left, and that is to divide by this 3. And so when I do that, I end up with 1 as an improper fraction that I'll just leave like that, negative 14 thirds. The other value of x is just going to be positive 4. So there it is, negative 14 thirds and 4 are the two solutions in my solution set. Next one here, notice the 3's on the outside of the absolute value bar. So let's get rid of that. The way I'm going to do that is divide by 3. And the 3's just cancel. I don't need to divide this stuff by 3 inside the absolute value bars because the 3's on the outside. It's a factor, so I'm just canceling that one factor out. But I have to do the same thing to the other side, and 3 does go into the 18 6 times. So it's a positive 6. That's good. I will actually have a solution here, and I'll go ahead and set that x minus 1 equal to the two values it could be. It could either be a positive 6 or negative 6. Now I put the 6 on the right side because typically on a number line you see the positives on the right side. So that's just why I decided to do that. And negatives on the left. And anyhow, I'll go ahead and add the 1 to all sides. And I end up with this negative 5 equaling x, but it can also equal 7. So those are our two answers, negative 5 and 7. So again, if you plug in the negative 5 in for x, you take away 1, makes negative 6. Absolute value negative 6 is 6 times 3 makes 18. You put the 7 in for x, 7 minus 1 makes 6. Absolute value positive 6 is 6. 6 times 3 is 18. So these answers that we are getting here work when we go ahead and plug in the values of those values in for x, or whatever variable we have, do the work, take the absolute value, we'll get the number. So as you can see, there are 3 different possible types of answers we can have. So the number of answers, we'll say, so absolute value equations, that is, because we also will deal with inequalities in a while, absolute value equations can have either 0, 1, or 2 solutions. So that's something to remember. So either 0, 1, or 2 solutions. Either a no solution, 1 solution, or 2 solutions, as we saw here. See, here we had 1 solution with negative 4 and 1, 2 solutions with these, and no solutions over here. So those are the types of problems we'll see on tonight's homework. Good luck.